Today on Capechi's Corner, we're going to look at square roots. A radical is an expression that has a square root. Here is our radical symbol here, and our radicand, that's the number or variables that are found underneath the radical sign. Now, a square root, if I have an example of b squared is equal to a, then b is a square root of a. We'll go into a little bit more detail about that in this lesson and the next lesson. Perfect squares we use a lot in a lot of different math classes. A perfect square is a square of an integer. So for instance, if I have the square root of 4, that is 2 because 2 times 2 is equal to 4. 4 is a perfect square because it is a number times itself. Another example of a perfect square is 9 because 3 times itself is equal to 9. Now, if I have something like the square root of 2, that doesn't go evenly. It's not taking an integer and squaring it. We get a decimal. So 2 is not a perfect square. Here we have a perfect square chart. All the numbers in red are perfect squares. So we have 1 squared, for instance, is equal to 1, 2 squared is equal to 4, and it goes on. You can use, obviously, your calculator to help you with this. We're going to use this again, the perfect square chart, in later lessons, so I do think it's a good idea to have this handy while you're working through this unit. So let's look at how we're going to use this perfect square chart. The first set of directions says to evaluate the expression. So in number 1 it says the square root of 81. Now I notice that 81 is on my perfect square chart. The square root of 81 is 9. So that answer is going to be 9 because 9 times 9, or 9 squared, is equal to 81. Now in number 2, we have a negative sign in front. So what that means, a square root symbol is a grouping symbol. So in order of operations, I'm going to do that first. So again, we just found that the square root of 81 is 9, and I'm going to multiply that by negative 1. So my answer here is negative 9. Now in number 3, this time I have plus or minus in front. So again, the same thing. Square root of 81 is 9. That's my grouping symbol. I'm going to do that first. I'm going to add plus or minus 9, which basically means we have 9 or negative 9. We just have that combined symbol just to cut down on the writing. Now in number 4, I have the square root of negative 81. So let's think about that. In that red list of numbers, there are perfect squares. Negative 81 is not on there. And if you notice, all of those numbers are positive because anytime I multiply a number by itself, it's going to give me a positive value. So for instance, if I'm looking at 9 again, 9 times 9 is 81. Even if I were to use negative 9 times negative 9 is still 81. So therefore, I can never have a negative radicand that's going to give me a real solution. So here we say no real solution. So let's look at some different numbers. Again, evaluate the expression. And in number 1, we have the square root of 256. So I can use my chart, and I realize that 256 is right here. So the square root of 256 is 16, because 16 times 16 gives us 256. In number 2, I have the negative square root of 49. So again, the square root of 49, that's my grouping symbol. That's 7 times negative 1. So my answer there is going to be negative 7. In number 3, we have the square root of 0. And 0 times 0 is 0. So that'll be our answer for number 3. In number 4, again, we have a negative radicand, negative 100. So again, we're going to say that this answer is no real solution. Now, the reason we say no real solution is when you get to different algebraic concepts, usually in Algebra 2, we use imaginary numbers. So that's why we usually state that there's no real solution. We just state that for now as we're starting this concept. Now we're going to evaluate some expressions, and this time we're not dealing with perfect squares, so we're going to use our calculator and we're going to round to the nearest hundredth. So in number 1, I have 6 plus or minus the square root of 7. Now there is no plus or minus key on the calculator. That's always the first question students ask. So we actually have to split this. So I have 6 plus the square root of 7 and 6 minus the square root of 7. Now when you get 6 plus the square root of 7 and you round to nearest hundredth, you get 8.65. And the second part of the 6 minus the square root of 7, you have 3.35. So again, every calculator works slightly different with the square root, so you just need to make sure you're comfortable with that function on your calculator. In number 2, we have 3 plus or minus 7 root 8 divided by 9. Now again, we're going to have to split it. So we have 3 plus 7 root 8 divided by 9, and then we have 3 minus 7 root 8 divided by 9. Now you have to be careful because the calculator always does the order of operations. So the way this problem is given to us originally, I need to make sure I figure out what the numerator is, get a value, divide by 9. So the first time I put this in my calculator, 3 plus 7 root 8 divided by 9, I get 2.53. And when I do it again with my negative sign, I get negative 1.87. So again, just remember that you need to figure out that numerator is first, divided by 9, and be comfortable with the functions on your calculator. Now the last thing we're going to do today is evaluate the expression, the square root of b squared minus 4ac, for the given values. And we like to practice with using this radical symbol and the radicand underneath before we get to quadratic formula, which we'll get to in the next few lessons. So I'm just going to substitute the values given. So in number 1, again, I have a square root sign, and I have 3 squared minus 4 times a, which is 2, times c, which is negative 5. Now, and that first value we have is squared. And because it's b squared, we know that we're going to square that every time in these examples. And anytime we square a number, we know we're going to get a positive value. So I know that number that's going to kind of hug that radical symbol is always going to be positive. Now, I know this next part of the expression gets a little confusing. So I usually tell students just concentrate on the sign first. So I have a negative, and a positive, and a negative. When I multiply those together, I get a positive value. Now I just have to worry about the computation, the number. So 4 times 2 times 5 gives me 40. And again, I already took care of the symbol, so I don't have to think about that, doing the signs and the computations all at the same time. So 9 plus 40 gives me the square root of 49. And I know that the square root of 49 is 7, so that's my answer. Looking at our last example for today, again, I'm going to do the same thing. So I have the square root symbol. My b value is negative 21, so I'm going to put that in parentheses and I'm going to square it. Minus 4 times a, which is 10, and times c, which is 9. So again, negative 21 times negative 21 gives me positive 441. Remember that first number that's hugging the radical sign will always be positive because I'm squaring it. Now again, if I look at my symbols, I have a negative and a positive and a positive. That's going to give me a negative. And then when I take 4 times 10 times 9, I get 360. If I subtract 441 minus 360, I get the square root of 81, which is 9.